Welcome back. I'm now on page 460 and we'll start with the number 5. And they have a little drawing for us. Let's see if I had a little box like that. I'll do it in yellow. So the box looks something like this, and then it has a bunch of lines. Let's see, it has a line like that. 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 And then they have a couple points here. They have, let me switch to the pen. And that's too dark. So you have point A, B, C, and D. And the question is, in the figure above, a path from point A to point D. A to point D is determined by moving upwards or to the right along the grid line. So you have to move along the yellow lines. How many different paths can be drawn from A to D that do not include either B or C? So we can't have either B or C in our path that goes from A to D. So the way I think about it is, which of the, if we call these yellow lines roads, I guess, which of these roads would be unusable if I can't go to B or to C? Well, let me mark the unusable roads. Well, unusable roads would be the roads that their only purpose is to get to B or go away from B, or get to C or go away from C. So, for example, this road right here, all it does is go towards B or go away from B, so we can't use that because we're not going to go through B. Similarly, we can't use that road, can't use this road, and we can't use this road, right? Because those are all the roads that come to and from B, so we're not going to use those. The only reason why you would use those roads is if you went through B, so you can't use those. And similarly, for C, same thing, you can't use that one, can't use that one, can't use that one, and can't use that one. So what are we left with? I mean, we might as well just erase those roads, right? Because they're kind of just messing up the picture, right? So let me just erase them. And I can, well, that's good. So let me erase all the roads that I can't use. I can't use any of these because I can't go through B or C. And then it's going to start looking a lot clearer. Then the problem gets really easy. So these are all the roads I can use to go from A to D. So how many paths are there? Well, I can go, that's one path, one. I could do this, two paths, three paths, four paths. And that's choice B. I hope I'm right. At least my choice exists. Problem number 6. Problem number 6. If 3/7 of n is 42, so if I write that algebraically, that's just saying 3/7 times n is equal to 42. And they want to know what 5/7 of n is. So they want to know 5/7 n. Well, to solve for n here, I just multiply both sides times the reciprocal. So let me do that. So 7 over 3. I'm just multiplying both sides of this equation by 7 over 3. So this cancels out, right? So we could say n is equal to 7 over 3 times 42. And now we want to know 5/7 times n. So we just take this n, place it here. So it'd be 5/7 times this thing, right? This is n, times 7 over 3 times 42. And notice I just kept it that way because the 7's ended up canceling out, so I had to do less arithmetic. So scratch those out. And then let's see, 5 times 42 over 3. Let's see, 42, what's 42 divided by 3? It's what, 14? Right, because 30 and 12, right? It's 14. So this goes to 1, this goes to 14. And 5 times 14 is 70. And that is choice A. So all you do is you can just solve for n and then multiply by 5/7. Not too fancy. This is probably one just to see how fast can you do this type of problem. Okay, clear image, invert. All right, I'm on problem number 7, and I'm getting sleepy. I'm just going to go to bed after this video. All right, the figure above. Well, let me draw the figure above. We have that. And then, let's see. You have, I don't even know what this figure is for just yet. And then they have, let's see, they say A, B, C, D, E, and F. And now let's read the problem. The figure above shows the top view of an open square box that is divided into 6 compartments with walls of equal height. Each of the rectangles D, E, and F have twice the area of each of the equal squares A, B, and C. So they're saying, D is twice the area of A, I guess, right? The way I drew it, it looks like a little more, but we know that this is twice the area of this. Okay. When a marble is dropped into the box at random, so it's kind of being dropped from above into this box, it falls into one of the compartments. What is the probability that it will fall into compartment F? So the way you really just have to think about it, okay, the marble has an equal chance of falling anywhere on this square. And so if you want to know the probability that it falls into F, you just have to figure out the fraction of the area that F is of the entire square. So if we said that A has an area of X, then B also has an area of X, and C also has an area of X. And they told us that these are twice these, so this would be 2x, this would be 2x, and this would be 2x. So the total area would be what? It would be x plus x plus x, so 3x plus 2x plus 2x. So these three are 6x plus 6x. So the total area is 9x, right? 9x is the total area of the box. I mean, we don't know how big x is, but 9x is the total area of the box. And f is 2x, right? F right here is 2x. So the area of f over total area, I don't like this toothpaste blue color, but we'll deal. So the area of f, I wrote here before I scratched it out, is 2x over the total area is 9x, and the x's cancel out. So f is 2/9 of this total, I guess, box's area. So there's a 2/9 probability that a marble dropped randomly on top of this box with kind of a uniform distribution anywhere in the box. There's a 2/9 chance that it will fall into, I guess, cubby E. Sorry, cubby F. And that's what they ask us in the question. And actually, it would also be a 2/9 that would fall into cubbyhole E because it's the same area. Okay, problem number 8. If A and B are odd integers, which of the following must also be an odd integer? Oh, these are fun. All right. So choice 1 they give is A plus 1 times B. Well, they say, can this be odd? Well, let's just try out some numbers. Let's say A and B are 3 and 5, right? These are two odd integers. If A is 3, then A plus 1 is 4 times 5. This equals 20. So we end up getting an even answer. And that makes sense because if you take an odd number, add 1, you get an even number, and anything times an even is even. So it's not going to be choice 1. Choice 1 is going to give us an even number, actually, no matter what. Choice 2. A plus 1 plus B. So we figured out that A plus 1, this is going to be even. And we know that B is odd. And you could try this out, but if you take an even number and you were to add an odd number to it, you're going to get an odd number. And that makes sense. I mean, you could try it out with a bunch of different numbers, but that's always going to happen. I mean, because if you add an even number to an even number, you get another even number, and if you add one more, an odd number, anyway, I think you get the point. And you could try it out with our 3 and 5 examples. That wouldn't prove it for sure, but it does work for that example. And then similarly, A plus 1 minus B, it's the same notion. I mean, you could try it out with some numbers, but if you have an even number here, because an odd plus 1 is even, and then you were to subtract another odd number, you would also get an odd number. So the choice is E. See you soon.